SmartLogic Semaphore is an open semantic platform that provides taxonomy management, automatic content classification, and taxonomy-driven search and navigation. This overview demonstrates the capabilities of the ontology management components. Many organizations are struggling to manage taxonomies or controlled lists in tools like Excel or Word. This body parts taxonomy is already getting quite long, and managing the relationships and ensuring that there's no duplicates is a complex task. Existing lists can easily be imported. The Excel file shown has been saved as a CSV and loaded directly. The software can use the ZTHERES industry XML standard for structured import to either the client or the server. Our professional services team can transform any candidate structure to ZTHERES for import into the system. The Windows client provides the interface to this server. We can have multiple models either held locally or on multiple servers. And opening our body part taxonomy, I have a much more intuitive interface where I can drill hierarchically up and down the structure or use the alphabetic search to find specific terms. Having loaded the basic structure, we can start manipulating the taxonomy. In this example, I'm going to make heart polyhierarchical, i.e. it has two parents, cardiovascular systems and internal organs. The simple drag and drop operation drops it in as a narrower term. Likewise, I could make a relationship between blood and circulation, in this case an associative relationship. Again, drag and drop creates the relationships between terms. Ontology Manager ensures an easy build of the taxonomy while maintaining the integrity of the system. If I want to break down the topic blood into narrower classifications, it's as easy as adding another preferred term as a child. Here I'm adding blood plasma. The term goes in, instantly reflected in the hierarchy. Information sciences will use a number of sources to research the terms used for their taxonomy. Here is an example. A Wikipedia page shows that blood cells is also a good breakdown for blood. Dragging the term directly into Ontology Manager will allow me to create that term. The term can be edited in place without the need to delete and recreate it. Enriching the taxonomy with synonyms helps the user for signposting terms and for classification evidence. Here, red blood cells is dragged into the equivalence term box, and automatically a use-UF relationship is created. This relationship type is an ISO standard for taxonomy development. In addition to hierarchical, associative, and equivalence relationships, term metadata and information can be stored. A basic item such as a scope note can be created. Here is being cut and pasted from the Wikipedia page. But any note, type, alternative ID, date field, etc. can be created and maintained alongside the term. With the mechanisms shown, we've built out the taxonomy. What I want to do now is drop the anatomy branch into my health ontology. I select the branch and choose copy term set, and then move over to my ontology and paste the branch in. Here I'm going to make sure there's mappings in case there are differences across the two structures, and I'm going to select a class of anatomy to paste that information into. With that simple bulk operation, I've dropped all the information from one model to the other. It's now available to be linked and used. The power of an ontology is to allow named relationships between classes of information. In this scenario, I want to create a relationship between the body parts, the anatomy branch, and conditions and diseases. As my user role has sufficient privilege, I can change the structure of the underlying model. Here the class anatomy needs to be linked to conditions or diseases. There are a number of relationship types we can create. I've created a type called effects, and I can map the source and target classes. So within the client, I now can make a relationship from hematological diseases using the relationship type effects to the class anatomy, where I will search for terms. The list is limited just to terms within that class, and I select blood. If I navigate to a different topic, for example diabetes, I can see the different relationships. Building up these name relationships allows us to create a dynamic knowledge map of the domain. In addition to enriching a topic by relating it to others, we can use our text miner tool to search content about a subject and create candidate phrases. Here are a number of web pages that are about a topic are analyzed, and the system identifies potential phrases that exist, with counts and whether the term is existing already in the model. As an information scientist, I can browse through, preview the term in context, and if I choose, drag it into the model. One of the goals of Ontology Manager is to make information scientists more productive, building, enriching, and copying elements of taxonomies. The model created needs to be reviewed and used throughout the organization. So here a different user is logging in as an approver role. Most of the menu options are grayed out for them. They're only allowed to choose whether a term should stay or be rejected from the actual taxonomy. Individually, we can select a term and approve it, or we may choose to look at a term and reject it. The system highlights this information in multiple colors, so black is approved, green is candidate, and red is rejected. We can do this on an individual basis, or we can approve whole branches of the taxonomy. Any discrepancies are flagged throughout the system, so maintaining the integrity of the model as a whole. The Properties tab shows us the term status and also an audit trail of any changes made by various users to the system. Once we've finalized it, the next step could be to generate a review pack. This populates an HTML view of the system, which editors, subject matter experts can browse through and understand. If they want to feed back on a particular term, they can post a comment. These comments are made centrally available, so the information scientists can choose to act on them. And once the taxonomy is at a review point, you may want to extract information out for other systems or other purposes. So the tool has export capabilities, both as flat reports or as XML outputs. For broader system integration, our Search and Enhancement server provides a high-speed XML API to the ontology or taxonomy information. Here a browse service can be called that shows me the top-level nodes, or a term service allows me to query a specific ID and bring back information, in this case, on our topic blood. This XML API service can drive many applications. Here a Flash widget is used as an explorer to the health ontology, but the information could be used to drive pop-up boxes in content management systems or faceted search widgets on enterprise search results applications. Semaphore Ontology Manager is a powerful platform that will manage the creation, development, review, and ongoing maintenance of your taxonomies or ontologies. For more information, please contact us on the numbers shown.